on permutations and combinations. I've selected every question from 2015 from all of the different versions of the exams that was a permutation or combination question. And we're going to work through them and see how many we can get done before 4 o'clock. Okay, so number 1, how many different numbers can be made by arranging all 9 digits of this here? 223,677,888. If there are no restrictions, so we can move all of these digits around, there's no restrictions. Okay, so how many digits we've got? 9. So if they were all different, we'd say it's 9 factorial, correct? But we've got some double ups. So what are we going to do? Divide by 2 factorial for this guy. What's this one? 2 factorial. This guy. Times 3 factorial. Equals. How many ways can we arrange the numbers, the digits? We got 15,120. Okay. Cool. Alright. Now, the next thing is, what about if we are making the number an even number? Okay. Now, if it's an even number, it has to end with this, or this, correct? But wouldn't it be easier to work out the number of ways we could make an odd number? Right? Because we've only got 3 odds and 6 evens, right? So if we work out the number of ways we could make an odd number, and then subtract it from this, that'll tell us the number of ways we can make an even number, yeah? Okay, so how can we make an odd number? Well, we've got 1, 2, 3, 4, 5, 6, 7, 8, and then the last one could be a 3. That's one way we can make an odd number. And the other way would be 1, 2, 3, 4, 5, 6, 7, 8, and the last one would be 7. Yeah? Okay. So let's consider this. How do we do this? Well, we've got 8 factorial here, don't we? So, because there's 8 other numbers that we have to rearrange. Yep. And then of those 8 that we have to rearrange, we've got this, this, and this. So it's going to be 8 factorial divided by the same thing again, isn't it? Okay, but what about this one here? Now we've got 8 other numbers that we have to arrange. But we're not going to have this, are we? We will have this, and we will have this. So it will be this. Okay, so those should be the possible ways of making an odd number. Now some of you might be thinking, Mr. K, you've forgotten the fact that there's 2 7s. Right? So you should times this by 2. But no, because remember, these 7s are the same. So what doesn't matter what 7 we've got here, right? So we're not going to times that by 2. So therefore, the number of ways we can make an even number must be 15,120 subtract this, 8 factorial over 2 factorial, 2 factorial, 3 factorial, minus, or maybe we'll put this in brackets, 8 factorial over 2 factorial times 3 factorial. Bracket there. Am I getting an answer for this? Rebecca, what did you get?
2080.
Correct. Is that what everybody's getting? Okay, cool. Obviously, this is that they're thinking maybe the young people might not understand what the word applications means. Sandra wishes to buy some applications, apps, for her smartphone, but she only has enough money for 5 apps in total. There are 3 train apps, 6 social network apps, and 14 game apps available. So, she wants to have at least one of each type of app. Find the number of different possible selections that Sandra can choose. Okay, so what have we got? We have 3 train apps. What's a train app? Okay, 3 train apps. What is the other one? Social ones. What is it? How many of them have we got? 6. 6 social ones, and then what's the last one? 14 games. Okay, and she has to have at least one, and she can afford a total of 5. Okay, so we think of the ways we can do this. Well, we could do one of these, and 3 of those. We could do one of these, 3 of these, 1 of those. 3, 1, 1. Anything else? 2, 2, 1. This is annoying, isn't it? 2, 1, 2, 1, 2, 2. Are there any other possible ways? Not if she has to have one of each. I think that's it. Yeah? Okay. Now I have to work out how does this work. Well, this row here, she's getting one of those, so it's going to be 3, choose 1, and then she goes and picks one from here, which is 6, choose 1, and what is 3, choose 1? It's just 3, right? 6, choose. So from now on, when it's got 1, I'm just going to go 6 or 3, right? And then this one is times 14, choose 3. The next line will be 3, choose 1, which is 3, times 6, choose 3, times 14. And then we should go this next one. 3, choose 3. What is 3, choose 3? You've got to choose all of them. There's only one way of choosing all of them, right? But if you're confused, you can always just write 3, choose 3. Then 6, choose 1, which is 6. And then 14, choose 1. 14. Next line, Meg Green, what have we got?
3, choose 2.
Yep.
6, choose 2. And 14.
This one, again, 3, choose 2, times 6, times 14, choose 2. Last line, 3, times 6, choose 2, times 14, choose 2. Then, what's our final step? This plus this plus this plus this plus this plus this. I would probably work out each step along the way. Right, so Beck, if you grab the first one, Hedwig next one, Lee for this one, Tiadia this one, Hassel this one, and I will do this one. Okay, first one.
6,552.
This one.
804.
This one.
84.
84. This one.
630.
630.
1638.
1638. Oh, that's me. I got 4095. Now let's add these all together. I'm getting 13839. 13,839. Oh, look at this. Find the number of different ways the 7 letters of the word bananas can be arranged. This is very helpful stuff. I'm sure you'll use it a lot. Okay, so let's have a look at the word bananas. I've got to spell it right. Is that right? Yep, I think it is. Okay, so first of all, we want the first letter to be an N, and the last letter to be B. Yeah? Well, oh, did I skip something? I think I did. I'll go back and do that later, okay? Sorry about that. Okay, so how many letters have we got in between these? Is it 5? Okay, alright. And of those, now how many different, we could have an N here, okay, and it doesn't matter if we've got another N there, it's the same situation as the previous question, that doesn't matter, we've only got one B. So we can rearrange these inner bits 5 factorial ways. Now, do we have any double ups there that might change things, Rebecca? The A's, and we've got 3 of them, so we're going to divide by 3 factorial. And that will tell us how many ways we can arrange this. Should be 20? Okay. Now the second thing here is if all the letters A are next to each other. So we could just go, alright, all the letters A are next to each other. So A. Then what are the other letters? B, N, S. Is that right? I think so. So we're going to treat this as one letter. Okay, and then we've got these ones. So all together we have 5. Okay, so this will be 5 factorial. And then what are we going to divide by? Because we've got some double ups here as well, don't we? This is a double up, this is a double up. So those ones could be divided by 2 factorial. Do we need to do anything with this? Because we could rearrange these A's, couldn't we? But it doesn't matter because they're exactly the same no matter which way you double it up. Okay. What is this? 5, 4, 20, 60. Okay, cool. What's the next bit? Oh, yes. So find the number of ways of selecting a group of 9 people. So we've got 9 people. From 14 people. If 2 people cannot both be in the group together. So in other words, we're going to have special case 1 and special case 2, and they're not allowed to be next to, they're not allowed to be together. And then you've got the rest of the people, so there's going to be 6, 7, 8, 9, 10, 11, 12. So these are 14 people, and we're selecting 9 people, and we can't have both of those people together. Right. So there's multiple ways you can do this, but sometimes the easiest is not the most intuitive. We could figure out the number of ways, total ways, that we could pick 9 people from 14 people. Then we could find out the number of ways that we have both of these people in the team, and then subtract that. So if we had no restrictions at all, we could just pick 9 people from 14, we would go 14, choose 9. That's with no restrictions. Why am I doing choose rather than P? P stands for permutations, right? And when we're picking a group, it doesn't matter the order that we're picking it in. That's why I'm using choose, right? What does this give us? A big number. What is it?
2002.
Is this one? Okay. Alright. Now let's find the ways that we actually select these guys and the team together. So we've already selected them. We're allowed to pick 9 people. So how many more can we pick from this group? You must pick 7 from how many left is that? There's 12 of them. So 12, choose 7. There's 12, choose 7 ways of getting these 2 people together. So if we do do 14 choose 9, subtract 12 choose 7, we'll get all of the ways that they're not in the team together. Which gives, well, I get 1,210 ways.